Okay, what we're going to do right now is we're going to look at this problem of an object coming down a hill. So let's put some, real quick, let's put some lines on that so we know it's moving down the hill. Now we're going to try to figure out how it's going to accelerate or pick up speed. In order to do that, we're going to begin with a force diagram. So let's go here and change this. There we go. Let's start with a force diagram. Now force gravity is going to, of course, pull it straight down. And force normal goes perpendicular to a surface and therefore comes up at an angle. Now if you think about it, we'll talk in just a second, but this force has just rotated over here by about 20 degrees because the surface has gone up by 20 degrees. And finally, that's force normal. And finally, we also have force friction going back. There we go. Force of friction. Let's give us some values for this problem here real quick. Let's say that the mass of the block is, let's make our lives easier, 10 kilograms. And let's say that the mu of this particular situation is, let's go 0.4. And what we're going to attempt to do is we're going to attempt to find the acceleration. Now before we do that, let's look at this particular picture. What we have going on here is we have the same hill at 20 degrees, and the hill again at 20 degrees. Now this is usually the way we look at our XY axis. Now in a problem like this where the object is accelerating down the hill, and that's very important to hear, it has to accelerate down the hill, we're going to rotate the axis so the axis matches the acceleration. So you can see here that in order to match the surface of the hill, or it's going to accelerate down the hill, I'm going to rotate the whole thing by 20 degrees. The positive x is going to come down, the negative y is going to come over, the negative x is going to come up, and the positive y is going to come to the right. And you can see in this new problem over here how it's been shifted. The dotted line here represents our old xy axis, and you'll note that everything has been shifted by 20 degrees. Again, this is so that the positive x-axis matches the direction of which way it's going to accelerate. Due to this, you can see that right here my old negative y-axis has rotated over by 20 degrees. Now you can see this whole thing done already, and if you want to pause right here, you can actually look all the work being done. Here I've got my force normal going up at an angle, which we showed just a moment ago. I have changed the mass slightly. It's 50 kilograms here, and I believe the mu is slightly different too. What is the mu value here? I believe it's we have 0.1, I believe, in this case. So in this particular problem, you can see that this is 20 degrees shifted over. My force normal falls entirely along my new y-axis. Force gravity no longer does, but it's going to act in the new y and the new x. So I begin this problem by showing how to find the force of gravity. Sum of forces equals mass times acceleration. Force of gravity is equal to mg. And therefore just take mass times g and get my force of gravity here. I then come over to step number 2 and I try to figure out what's my force of gravity in the y and my force of gravity in the x. You can see that I've taken this circled portion right here and just moved it slightly over. I use trig. I can see that because this is my angle of 20 degrees here, that I would want to find this side, and that's adjacent, and therefore I have to use cosine in order to figure out how much force gravity is in the y. In order to figure out how much force gravity is in the x, that's my opposite, so I use sine to get this value right here. Once I have these values for both x and y, I come down here and I sum the forces in the y. I do that in order to find how much force normal I have. It's necessary to find force normal because in just a moment we're going to use that to find force friction. So I sum the forces equal to this, and that's equal to 0 because it's not accelerating in the y. Now many people have asked me, why is it not accelerating in the y? Well, what you can see is that it used to, but this is my new x. Now let me show you something else. The pink here represents our acceleration. You'll notice that it used to go down in the y, but because we've shifted our axis over, you can see that this being my axis, that this acceleration falls entirely along the new x. So since this is my new y, and there's none going that way, my acceleration in the new y is 0. Now that I know my acceleration is 0, force normal will equal force gravity, which equals that 460.45, which we solved right up here. I use that 460.45 with my new mu to find how much force friction is. Since it's 0.1, very, very small surface here, must be ice or something, I got 46.05. And then the final thing that I did is sum the forces in the x in order to find the acceleration of this object. So I use force gravity in the x, which we calculated already right here. And then I use force friction, which I just calculated, subtract it because it's going negative, and that's equal to 50 kilograms times acceleration. So I take my sum divided by 50, and there's my final answer. Now you've just seen how to do that problem, so if you're still struggling with these problems, what I suggest you do is you take these numbers right here and attempt to do this problem entirely on your own without looking at the work. If you need the work, look at the work for a second because you're stuck, that's fine. But I suggest you try to do it without. What I'll do is pause for a few seconds here. I'll tell you when to pause, and then I'll do the work, and then you can check your work here at the end. So pause it now. And there we go. There's your final answer. Take a pause for a second. You can see how the thing was worked. It worked exactly the same way. An interesting result of this particular one is you'll find that force gravity in the x is not as big as force friction, and so force friction is negative. Now that's okay in this problem because we already said that the object was moving, and so that just means that the object is going to slow down.